Hi, everyone. My name's Alan Shreve. I'm at Inconceivable on the internets. Follow me on Twitter. I build ngrok.com. Hands up who uses ngrok. All right, the rest of you. So today we're going to talk about service-oriented architecture without the pain. Do I mean microservices? Sure. You're building a cloud service for whatever reason, and this time you're going to do it right. This time you're not going to build any monoliths. There's not going to be any chef. You are the cloud crusader, and you have come prepared with your set of tools to build your cloud service the right way this time, in a way that it will scale, in a way that you won't have to deal with the pain of managing your mono repo and teams conflicting on changes. And so with you, you're bringing your tools, you're bringing containers and service discovery and a job scheduler to farm your jobs over the nodes in your entire infrastructure, and all sorts of other tricks that you need to do to make all of this work. So you build something where you have multiple servers and you schedule all of your services onto them. But of course, you can't just do that. You need something to orchestrate them. So you add your orchestration layer. And then you need agents running on all of the boxes. And you need network routers to have all the services communicate with each other. And then finally, they can all dynamically find out where they are and communicate. And eventually it will work, but when you start out, there's a lot of pain in that. And there have been a lot of people talking about the premium that you pay on microservice architecture and service-oriented architecture. And that comes in a lot of different forms. A lot of the tools are still very alpha. You're often building on tools that are changing very, very rapidly, and so something that you might build today, you might have to update very frequently in order to catch all the new bug fixes. And in addition, all of these different components are still not settled. There are no standard protocols. When someone builds a better container engine, a better service discovery engine, you can't swap them out. There's no standard way for all of those to work. So what if we could have the best of both worlds? So I want to introduce you to the ngrok architecture, the way that the backend services for ngrok work. And it looks like this. And you might look at that. That's all one box, by the way. You might look at that and say, that looks kind of familiar. Oh my God, it's a monolith. So I want to introduce to you the concept of the Lego monolith. The Lego monolith looks like a monolith, but instead of building a single application that runs on one box, you build a service-oriented system, but run all of them on the same box. When you want to make an RPC call from one service to another, you do it over loopback. You never have to worry about service discovery because every service runs on every box, and every service runs on the same port on every box. And it's horizontally scalable. You can scale it out and run as many of these as you want. When you want to route into the cluster, you can pick a certain set of boxes that are your balancers and set up DNS to route to the particular services that handle balancing on each box. And there are, of course, exceptions. The exceptions being sometimes you do actually have to communicate across boxes. And so there are some services, the balancer services, notably in ngrok's case, that will actually farm requests out to different boxes connections. And so in many ways, this pattern is just like a monolith. There's no dynamic service scheduling. There's no orchestration complexity. All of the boxes run the exact same image of all of the servers. There are no discovery problems. All of your services run on every box, and they all run on the same port on every box. So you already know exactly where to find the service that you want to talk to. And there are much fewer distributed systems problems, right? Most of your calls are going over loopback. You don't have to worry about the network dropping your packets. Hopefully over loopback. But it also gets you a lot of the benefits of microservice and service-oriented design. These are all small, self-contained pieces. You can build services that have the single responsibility principle. You also get independence of deployments, right? I can deploy one of these services without touching any of the other ones. You get independence of development, right? I can work on one of these services, someone else can work on one of these services without any conflicts. You even get independence of failure, somewhat, not if your service takes down the whole box and causes kernel panics, but if it runs out of file descriptors, you've only knocked out that one service and not all of them. In addition, it also doesn't lock you into a particular language or framework. You can build each service in a different language if you need to, if there's a particular language or framework that suits the job. This doesn't scale indefinitely. It doesn't work up to Google scale, to Amazon scale. But most of us don't run at Google and Amazon scale. Most of us run with tens of servers, hundreds of servers. And I don't know if this scales up to hundreds of servers, but it definitely works at tens. But most importantly about this is it gives you a clear path from this particular design, this monolithic design with all of its benefits, to this design. Because you've already split out all of your services into different pieces, having them communicate over this sort of system is actually pretty easy because you've already separated everything. Everything is already communicating over RPC, and so actually adding all of these layers of orchestration and discovery is a very easy step once you're ready to do all that. So that's the Lego monolith. Tell your friends. I'm incontributable on the internets. Thank you, and if you guys have any questions, let me know.